Okay, here we are again. Now let's check out this problem. This is a problem that it looks easy, and actually it is easy. But the only concern with this problem is that you have to work the geometry a little bit in order to be able to solve that problem. So let's read the problem. It says the smooth disks D and E have a weight of 200 and 100 pounds respectively. So that means this weight here is going to be 200 and this one here is going to be 100. If a horizontal force of P equal 200 pounds also is applied at the center of the disk E, determine the normal reactions at the points of contact. Even if it doesn't say determine the normal reactions at the point of contact with the ground A, B, and C, you should be able to know what reactions are produced here. Because you know this contact here is basically like a roller, acts like a roller, or like a smooth surface. That means there is no friction force opposing to this one. So the only force that this can produce is a force here, Cy, and By, and a force at A. Now let's solve this problem by using two methods. The first method that we're going to be using, it relates with also support reactions, which is what we are doing now, but it deals with particle equilibrium. Particle equilibrium, but I don't see any particle here. Well, you will see the particle if you start analyzing it. Remember, the first thing that we have to do is free body diagram. So I'm going to do a free body diagram of this portion, and I'm going to do equilibrium around the point or the disk E. So if we do that for the disk E, then we have, this is the disk, this is the center of the disk E. Then we have this force of 200 applied at the center, which is basically here. And then you're going to have a normal force acting, well, you're going to have this force also here, the normal force, Cy, which you can translate also up to the center. You have the weight, which is basically at the center, and is 100. Remember, all the units are pound. I'm not putting the units for not complicating more the drawings, but you have to keep the units in mind. And then between this one and this one, there is a force acting. This force is pushing that, but at the same time, this is pushing the other one. And because it's the point of contact between the two diameters, what I'm going to have is the force acting here. And I'm going to call that force dE, which also is directed to the center. Basically, what we are doing is particle equilibrium around that point. And this is the same problem that we have solved several times in different occasions. The only, I'm not going to say issue, because it shouldn't be an issue, is calculating this angle. And I'm going to call that angle alpha, because that angle is the one that is going to give me the horizontal and vertical projections for that normal force, or that force between the two elements, the two disks. So how do we calculate that? Well, remember you have these two disks, right? Big disk here and a small disk here, and both of them are at the same level here. This is the center of this one, and this is the center of this one. So basically you have this triangle between the two disks. Do you know this distance between both disks? Yes, you do know that because this is 1.5 and this is 1, meaning this distance is going to be 2.5 feet. Do you know the distance, the vertical distance between these 2 points? Yes, you do know that because you know this is 1.5 and this is 1, meaning this is 0.5 feet. Do you know the horizontal here? Well, yes, of course you know it because this is a right triangle. And then you can say that this horizontal is the square root of this square plus this square, which is 2.45. By having those, you can perfectly say that alpha, which is this angle here, if you want to calculate alpha, you can say that sine alpha, if you want to, is the opposite, which is 0.5 divided by the hypotenuse, which is 2.5, which gives you an angle alpha to be the inverse sine of this, and alpha will be 11.537 degrees, if you want to calculate it. I said if you want to calculate it because you can use this triangle now that we have the triangle. And you can say that the horizontal component of DE is 2.45 divided by 5 multiplied by DE. And the vertical component is 0.5 divided by 2.5 multiplied by DE. Or you can do just sine and cosine of the angle. So once we have that, we can proceed to this particle equilibrium here, and we can say that summation of forces in X equals 0. And if we do that, we have this component and this force. The horizontal component of this one will be dE cosine alpha minus 200 equals 0. I know the angle alpha because I calculated, and even more, I know the cosine. The cosine is 2.45 divided by 2.5 multiplied by this one, which gives me a value of dE of 204.12 pounds. And now we can do summation of forces in Y equals 0, and then you have the vertical component of this force is dE sine alpha minus this force 100 plus Cy equals 0. And I know the E and I know the angle, so I can plug this into here and I can solve for Cy, which is 140.82 pounds. So once we solve for these two forces here, I already have this one, but I still need to calculate this one and this one. As a matter of fact, I wasn't asked to calculate this one. But now I have to move to the other particle equilibrium, to the other disk. And if I move to the other disk, then remember what we have is this, and the disk is going to be here. Then the normal force is going to be acting at this end, and the other normal force is going to be acting here. Give me a second. Okay, so we have this force here, which is Vy, and we have this force here, which is A, the normal force. That's how we call it. And we have the inclination of this plane. That means this is going to be 3, 4, 5 angle, which basically is giving us also this angle is 3, 4, 5, and this is the complementary angle to that one. So 3, 4, 5 basically gives you a, this is 3, 4, 5, this is going to be 3, yeah, this is 3, 4, 5 also, or 3, 4, 5 also in this case. Yes, this is 4, 5, this, see, that's what happened. So basically when you have this angle here, 3, 4, 5, you know this angle is this one, and if this is the complementary angle, then this is going to be switched to 4, 3, 5 for this one. Now, it doesn't matter if you don't understand what I'm saying here exactly, But you can calculate also this angle and say beta, right? And this is beta. This angle here is 90 degrees minus beta. 345. Beta means it's going to be 36.86 or 87 degrees. This is this angle. Meaning this angle here is going to be the complementary, which is going to be 53.13 degrees. Or 435, which is the same thing. Okay, now this force is here, this force is here. We also have the weight acting in this part, and we have the normal coming from this other side, which we know, and is the E, and we know this angle also, because this angle here is alpha, and we calculated alpha before. Now, once we have this system, we can do summation of forces in X equals 0 for the disk D, and then we're going to have that the force A multiplied by 4/5 minus dE cosine alpha equals 0. I know the E and I know alpha. Then A is going to be 250 pounds. Now, if I do summation of forces in Y equals 0, then I'm going to have 3/5 of A minus 200. Remember, 3/5 of A is this component, which is basically this component here, minus 200, which is the weight, plus By, and then I have the vertical component here, which is plus dE sine alpha equals 0. Once again, I know A, I know dE here, and I know sine alpha, and this is going to give me a value for By equal at 9.18 pounds. There you go. This is a way of solving that, and basically if you realize and if you check it, there's no complication here. You do particle equilibrium. The only complication is understanding this angle and this angle. That's it. That's the first method. Now the second method deals with rigid body equilibrium. Why rigid body equilibrium? Because then I'm going to start, for the second method, I'm going to get the whole thing. I'm not going to break it up into one particle and one particle. I'm going to use the whole structure, the complete structure for that. Yes, the complete structure for that. So, remember we had the force here of 200 and the force here, which is the weight of 100, and this is 200. And remember we had this triangle that we defined before, meaning I know this height is 0.5 and I know this distance is 2.45 because we calculated before also as part of the first method, but you easily can calculate them because we already did. Now this angle here is 53.13 and this angle here is 36.87 degrees. What else? We have the force here, A, and if we check for the components of the force, once again, I know this angle, this angle here is 53, meaning this angle is 53, meaning this angle here is 36.87. And the horizontal component then is going to be A cosine 36.87, and the vertical component is going to be A sine 36.87 degrees. We have BY, and we have CY, and we have this distance, which is 2.45, but we don't have the horizontal distance between this force and this force, or this point A and point B, and we're going to need that. But we can calculate it. We can? Yes, we can, because look, this is 1.5, which is the diameter of that. And I know this angle, which is 36.87. So basically, I'm going to put this in red marker. So basically, this part, this angle is 36.87. So basically, this component here, or this distance, is going to be 1.5 times cosine of 36.87, which is 1.20 meters. And the total red distance here is going to be 1.5 sine 36.87, which is 0.9. And I knew before this is 0.5, meaning the distance from here to here is 0.4. I told you it's a lot of geometry. Now 0.4 is that if you prolong this line here, the distance, total distance from this point to the base is 1, because that's the radius. And I know this part from here to here is 0.9 0.9 is from here to here. This is 0.5, this is 0.4, this distance, meaning this distance from here to here, in case I need it, is 0.6. Okay, now we have all the distances that we need. And then you have these force CY, BY, and A are our unknowns. We have 3 unknowns, and we have 3 equations, so we can solve that. How do we solve that? Well, we can start by doing summation of forces in X equals 0. And if I do that, then I have this component here, A cosine 36.87. What else do I have in X? Just this one. Minus 200 equals 0. And I can solve for A equal 250 pounds, which is the value that we got before here, 250 pounds. And also, then I can do summation of forces in Y equals 0. And if I do that, I have A sine 36.87 plus BY plus CY minus 200 minus 100 equals 0. A is this, sine 150, negative 150. So from here I can get one equation that says BY plus CY equal 150. That's my equation 1. Now I can go here and do summation of moments about the point A equals 0. And I'm going to assume that counterclockwise is positive. I'm going to be here. So if I'm at this point, I'm going to start with this force here. It's going to be 200 times the distance. The distance is 1.2. Rotation is going to come in this direction, and that direction is opposite to this one, so it's going to be negative. Now I have BY, vertical force, multiplied by horizontal distance in this direction, plus 1.2. 1.2 Py. Now this other 100 force here, which is the weight, 100 negative multiplied by the distance from here to here, and the distance from here to here is 1.2 plus 2.45 plus cy multiplied by the same distance. Anything else? Anything else? Anything else? Anything else? Oh yeah, this force. This force is going to be acting in this direction, so it's going to be plus 200 times 0.4 equals 0. Now, I have my unknowns here. Our unknowns are Vy and Cy, same as here, Vy and Cy. So I can establish an equation. This equation is going to be 1.2 Vy plus 3.65 Cy equal 345, 365, 525. And I have another equation. Then I get the equation 1 and equation 2, and I solve by any method that you want to. You can just divide this by negative 1.2 or multiply this by negative 1.2, add the map, and solve. And when you solve, you get Cy equal 140.8 pounds and Vy equal 9.2 pounds, which are the same values that we got here before. Vy 9.18 or 9.2 and Cy equal 140.82 pounds. So you have two methods for solving this problem. You know, this is a typical example of a problem that looks really easy to solve. And it's not complicated, but you have to work a lot. So I hope that you like this problem, and I'll see you in the next video. Thank you for watching.